Dear viewers, I am your host Muhammad Asif Chija and you are watching YouTube channel ETV786, which is specially designed and created for business students. We are presenting course number 7, Business Statistics. Please view, like, share and comment the videos and subscribe the channel for upcoming shows. Courses available on YouTube channel ETV786 are number 1, Accounting, number 2, Business Management, number 3, Business Law, number 4, Business Taxes, number 5, Business Mathematics, number 6, Insurance and its types, and now presenting number 7, Business Statistics.
Previously, in part 1, we have learned the definitions, types, importance of statistics, data organization and graphical representation, etc. Now in part 2, we will study number 1, measures of central tendency and number 2, measures of dispersion.
So viewers, let's start the course number 7, Business Statistics. Measure of central tendency. A measure of central tendency is a summary statistic that represents the center point or a typical value of a data set. These measures indicate where most values in a distribution fall and are also referred to as the central location of a distribution. You can think of it as the tendency of data to cluster around a middle value. In statistics, the three most common measures of central tendency are the mean, median, and mode. Each of these measures calculates the location of the central point using a different method. Choosing the best measure of central tendency depends on the type of data you have. Arithmetic mean. The mean or average is the most popular and well-known measure of central tendency. It can be used with both discrete and continuous data. Although its use is most often with continuous data, the mean is equal to the sum of all the values in the dataset divided by the number of values in the dataset. So, if we have n values in a dataset and they have values x1, x2, so on to xn, the sample mean, usually denoted by x bar, pronounced as x bar. Here is a formula for ungrouped data and grouped data and a simple example of calculating the mean. Disadvantage of mean. The mean has one main disadvantage. It is particularly susceptible to the influence of outliers. These are values that are unusual compared to the rest of the dataset by being especially small or large in numerical value. For example, consider the wages of staff at a factory below. Here in the example, the salary of staff number 9 and 10, 90k and 95k, which are unusual compared to the rest of the dataset. Disadvantage of mean example. The mean salary for these 10 staff is $30.7k. However, inspecting the raw data suggests that this mean value might not be the best way to accurately reflect the typical salary of a worker, as most workers have salaries in the $12k to 18k range. The mean is being skewed by the two large salaries. Therefore, in this situation, we would like to have a better measure of central tendency. Taking the median would be a better measure of central tendency in this situation. Geometric mean. A geometric mean is a mean or average which shows the central tendency of a set of numbers by using the product of their values. For a set of n observations, a geometric mean is the nth root of their product, as shown in the box below. Geometric mean of two or three numbers. The geometric mean of two numbers, say a and b, is the square root of their product, and for three numbers, it will be the cube root of their products, as shown in front of each. Relation between geometric mean and logarithm. In order to make our calculation easy and less time consuming, we use the concept of logarithms in the calculation of geometric mean. Since geometric mean is the nth root of product of the observations, taking log on both sides, we have the geometric mean is equal to antilog of sum of log x divided by n, where n is the number of observations. Geometric mean and frequency distribution. For a grouped frequency distribution, the geometric mean is sum of nth root of product of frequency distribution. Geometric mean for group data is calculated by the formula as shown below. Properties of geometric mean. Number 1. The logarithm of geometric mean is the arithmetic mean of the logarithms of given value. Number 2. If all the observations assumed by a variable are constant, say k is greater than 0, then the geometric mean of the observation is also k. Number 3. The geometric mean of the ratio of two variables is the ratio of the geometric mean of the two variables. And number 4. The geometric mean of the product of two variables is the product of their geometric means. Geometric mean of combined group. Suppose G1 and G2 are the geometric means of two series of sizes n1 and n2 respectively. The geometric mean G of the combined group will be as follows. In general, for ni geometric mean I is equal to 1 to k, we have geometric mean is equal to antilog of n1 log G1 plus n2 log G2 carry on to nk log gk divided by n1 plus n2 plus carry on to nk. Advantages and disadvantages of geometric means. Number 1. A geometric mean is based upon all the observations. Number 2. It is rigidly defined. Number 3. The fluctuations of the observations do not affect the geometric mean. And number 4. It gives more weight to small items. Now disadvantages of geometric mean. Number 1. A geometric mean is not easily understandable by a non-mathematical person. Number 2. If any of the observation is 0, the geometric mean becomes 0. And number 3. If any of the observation is negative, the geometric mean becomes imaginary. Harmonic mean. A simple way to define a harmonic mean is to call it the reciprocal of the arithmetic mean of the reciprocals of the observations. The most important criteria for it is that none of the observations should be 0. A harmonic mean is used in averaging of ratios. The most common examples of ratios are data, speed and time, cost and unit of material, work and time, etc. The harmonic mean of an observation is as follows. And in the case of frequency dispersion, the harmonic mean will be as shown below. Properties of harmonic mean. Number 1. If all the observations taken by a variable are constant, say k, then the harmonic mean of the observation is also k. Number 2. The harmonic mean has the least value when compared to the geometric mean and the arithmetic mean. Advantages and disadvantages of harmonic mean. Advantages. Number 1. A harmonic mean is rigidly defined. Number 2. It is based upon all the observations. Number 3. The fluctuations of the observations do not affect the harmonic mean. And number 4. More weight is given to smaller items. Disadvantages are number 1. Not easily understandable, and number 2. Difficult to compute. Example of harmonic mean. Problem. Calculate the geometric and harmonic mean of the given data, where observations x is equal to 2, 4, 5 and 8 and their frequency is 3, 3, 2 and 2 respectively. Solution. Geometric mean. To find the geometric mean, we need the value of n, and here the n is equal to the sum of frequency, that is equal to 10. Then putting the values in the formula, we will get the geometric mean is equal to 3.9. And when we put the value in the harmonic mean formula, the harmonic mean of this problem comes to 3.45. Median for odd number of scores. The median is the middle score for a set of data that has been arranged in order of magnitude. The median is less affected by outliers and skewed data. In order to calculate the median, suppose we have the data below. We first need to rearrange that data into order of magnitude, that is smallest first. Our median mark is the middle mark, in this case 56 highlighted in bold. It is the middle mark because there are 5 scores before it and 5 scores after it. This works fine when you have an odd number of scores. Median for even number of scores. What happens when you have an even number of scores? What if you had only 10 scores? Well, you simply have to take the middle 2 scores and average the result. So if we look at the example below, we first need to rearrange data into order of magnitude, that is smallest first. Only now we have to take the 5th and 6th score in our data set and average them to get a median of 55.5. Percentile. A percentile is a measure at which that percentage of the total values are the same as or below that measure. For example, 90% of the data values lie below the 90th percentile, whereas 10% of the data values lie below the 10th percentile. Quartile. Quartile are values that divide a part of a data table into 4 groups containing an approximately equal number of observations. The total of 100% is split into 4 equal parts, 25%, 50%, 75% and 100%. The first quartile or lower quartile, that is Q1, is defined as the value that has an F value equal to 0.25. This is the same thing as the 25th percentile. The third quartile or upper quartile, that is Q3, has an F value equal to 0.75. The interquartile range IQR is defined as Q3 minus Q1. How percentile and quartiles are computed? The F value of each value in the data table is computed as Fi is equal to I minus 1 divided by n minus 1, where I is the index of the value and n the number of values. The first quartile is computed by interpolating between the F values immediately below and above 0.25 to arrive at the value corresponding to the F value 0.25. The third quartile is computed by interpolating between the F values immediately below and above 0.75 to arrive at the value corresponding to the F value 0.75. Any other percentile is similarly calculated by interpolating between the appropriate values. Mode. The mode is the most frequent score in our dataset. It represents the highest bar in a bar chart or histogram. You can therefore sometimes consider the mode as being the most popular option. Normally the mode is used for categorical data which we wish to know which is the most common category, as illustrated below. Two modes. We can see above that the most common form of transport in this particular dataset is the bus. However, one of the problems with the mode is that it is not unique, so it leaves us with problems when we have two or more values that share the highest frequency, such as shown below. This is why the mode is very rarely used with continuous data. Mode examples. For example, consider measuring 30 people's weight to the nearest 0.1 kg. How likely is it that we will find two or more people with exactly the same weight, such as 67.4 kg? The answer is probably very unlikely. Many people might be close, but with such a small sample of 30 people and a large range of possible weights, you are unlikely to find two people with exactly the same weight, that is, to the nearest 0.1 kg. This is why the mode is very rarely used with continuous data. When mode is far away. Another problem with the mode is that it will not provide us with a very good measure of central tendency when the most common mark is far away from the rest of the data in the dataset, as depicted in the diagram below. To use the mode to describe the central tendency of this dataset would be misleading.
Measures of dispersion.
Dispersion in statistics. Dispersion is the state of getting dispersed or spread. Statistical dispersion means the extent to which numerical data is likely to vary about an average value. In other words, dispersion helps to understand the distribution of the data. Measures of dispersion. In statistics, the measures of dispersion helps to interpret the variability of data, such as to know how much homogeneous or heterogeneous the data is. In simple terms, it shows how squeezed or scattered the variable is. Types of measures of dispersion. There are two main types of dispersion methods in statistics, which are number 1, absolute measure of dispersion, and number 2, relative measure of dispersion. Absolute measures of dispersion. An absolute measure of dispersion contains the same unit as the original data set. The absolute dispersion method expresses the variations in terms of the average of deviations of observations like standards or means deviation. It includes range, standard deviation, quartile deviation, etc. Types of absolute measures of dispersion. Number 1, range. It is simply the difference between the maximum value and the minimum value given in the dataset. Example 1, 3, 5, 6 and 7. The range is equal to 7 minus 1, that is equal to 6. Number 2, variance. Deduct the mean from each data in the set, square each of them and add each square and finally divide them by the total number of values in the dataset to get the variance. And number 3, standard deviation. The square root of variance is known as the standard deviation. Types of absolute measures of dispersion. Number 4, quartiles and quartile deviation. The quartiles are values that divide a list of numbers into quarters. The quartile deviation is half of the distance between the third and the first quartile. Number 5, mean and mean deviation. The average of number is known as the mean, and the arithmetic mean of the absolute deviation of the observations from measures of central tendency is known as the mean deviation, also called mean absolute deviation. Relative measures of dispersion. The relative measures of dispersion are used to compare the distribution of two or more data sets. This measure compares values without units. Common relative dispersion method includes number 1, coefficient of range, number 2, coefficient of variation, Number 3, coefficient of standard deviation. Number 4, coefficient of quartile deviation. And number 5, coefficient of mean deviation. Coefficient of dispersion. The coefficients of dispersion are calculated along with the measures of dispersion when two series are compared that differ widely in their averages. The dispersion coefficient is also used when two series with different measurement units are compared. Coefficient of dispersion is denoted as CD. Common coefficient of dispersions. Coefficient of dispersion in terms of range is equal to x maximum minus x minimum divided by x maximum plus x minimum. In terms of quartile deviation, it is equal to Q3 minus Q1 divided by Q3 plus Q1. In terms of standard deviation, it is equal to standard deviation divided by mean. And in terms of mean deviation, it is equal to mean deviation divided by average. Coefficient of dispersion. Example 1. Find the variance and standard deviation of the following numbers. Solution. First, we calculate the mean, that will equal to 5.75. Then step number 1, subtract the mean value from individual value, and we will get minus 4.75, minus 2.75, minus 0.75, minus 0.75, 0.25, 1.25, 3.25, and 4.25 respectively. Then step number 2, sparing the above values, we get 22.563, 7.563, 0.563, 0.563, 0.063, 1.563, 10.563, 18.063 respectively. Then step number 3, adding the squares value, we will get 61.504. Step number 4, n is equal to 8. Therefore, variance is equal to 61.504 divided by 8. That will be equal to 7.69. Now the standard deviation will be 2.77, which is the square root of 7.69. Coefficient of dispersion. Example 2. Calculate the range and coefficient of range for the following data. Values are 45, 55, 63, 76, 67, 84, 75, 48, 62, and 65. Here the maximum value is equal to 84 and minimum or least value is equal to 45. Then range will be maximum value minus minimum value, that will be equal to 84 minus 45, that will be equal to 39. Then coefficient of range will be equal to x maximum minus x minimum divided by x maximum plus x minimum. That will be equal to 84 minus 45 divided by 84 plus 45. That will be equal to 39 divided by 129 and further equal to 0.302 approximately. Skewness and kurtosis. Skewness essentially measures the symmetry of the distribution, while kurtosis determines the heaviness of the distribution tails. The understanding shape of data is a crucial action. It helps to understand where the most information is lying and analyze the outliers in a given data. Skewness. If the values of a specific independent variable feature are skewed depending on the model, skewness may violate model assumptions or may reduce the interpretation of feature importance. In statistics, skewness is a degree of asymmetry observed in a probability distribution that deviates from the symmetrical normal distribution in a given set of data. Normal distribution and skewness. The normal distribution helps to know a skewness. When we talk about normal distribution, data symmetrically distributed, the symmetrical distribution has zero skewness as all measures of a central tendency lies in the middle. Asymmetrical data. When data is symmetrically distributed, the left-hand side and the right-hand side contains the same number of observations. If the dataset has 90 values, then the left-hand side has 45 observations and the right-hand side has 45 observations too, as shown in the black outline picture. But what if not symmetrical distributed? That data is called asymmetrical data, and that time skewness comes into the picture as shown in the red outline. Types of skewed. Number 1, positive skewed or right skewed. In statistics, a positively skewed distribution is a sort of distribution where, unlike symmetrically distributed data where all measures of the central tendency, mean, median, and mode equal each other, with positively skewed data, the measures are dispersing, which means positively skewed distribution is a type of distribution where the mean, median, and mode of the distribution are positive rather than negative or zero. Properties of positive skewed. In positively skewed, the mean of the data is greater than the median. A large number of data pushed on the right-hand side. In other words, the results are bent towards the lower side. the mean will be more than the median, as the median is the middle value and mode is always the highest value. Limitations are positive skewed. The extreme positive skewness is not desirable for distribution, as a high level of skewness can cause misleading results. The data transformation tools are helping to make the skewed data closer to a normal distribution. For positively skewed distributions, the famous transformation is the log transformation. The log transformation proposes the calculations of the natural logarithm for each value in the data set. Types of skewed. Number 2, negative skewed or left skewed. A negatively skewed distribution is a straight reverse of a positively skewed distribution. In statistics, negatively skewed distribution refers to the distribution model where more values are plots on the right side of the graph, and the tail of the distribution is spreading on the left side. Properties of negative skewed. In negatively skewed, the mean of the data is less than the median, a large number of data pushed on the left-hand side. Negatively skewed distribution is a type of distribution where the mean, median, and mode of the distribution are negative rather than positive or zero. Median is the middle value and mode is the highest value, and due to unbalanced distribution, median will be higher than the mean. Range of Pearson's correlation value. As Pearson's correlation coefficient differs from -1 perfect negative linear relationship to +1 perfect positive linear relationship, including a value of 0 indicating no linear relationship. When we divide the covariance values by the standard deviation, it truly scales the value down to a limit range of -1 to +1. That accurately the range of the correlation values. So Pearson's first coefficient is equal to mean minus mode divided by standard deviation. Limitations of Pearson's first skewness coefficient. Pearson's first coefficient of skewness is helping if the data present high mode. But if the data have low mode or various modes, Pearson's first coefficient is not preferred, and Pearson's second coefficient may be superior as it does not rely on the mode. Pearson's second skewness coefficient. Pearson's second coefficient of skewness multiply the difference by 3 and divide the product by standard deviation. So Pearson's second coefficient is equal to 3 into mean minus median divided by standard deviation. Properties of Pearson's second skewness coefficient. Number 1. If the skewness is between minus 0.5 and 0.5, the data are nearly symmetrical. Number 2. If the skewness is between -1 and -0.5, negative skewed are between 0.5 and 1 positive skewed, the data are slightly skewed. If the skewness is lower than -1 negative skewed or greater than 1 positive skewed, the data are extremely skewed. Kurtosis. Kurtosis refers to the degree of presence of outliers in the distribution. Kurtosis is a statistical measure whether the data is heavy-tailed or light-tailed in a normal distribution. Kurtosis in finance. In finance, kurtosis is used as a measure of financial risk. A large kurtosis is associated with a high level of risk for an investment because it indicates that there are high probabilities of extremely large and extremely small returns. On the other hand, a small kurtosis signals a moderate level of risk because the probabilities of extreme returns are relatively low. Excess kurtosis. The excess kurtosis is used in statistics and probability theory to compare the kurtosis coefficient with that normal distribution. Excess kurtosis can be positive leptokurtic distribution, negative platykurtic distribution, or near to zero mesokurtic distribution. Since normal distributions have a kurtosis of 3, excess kurtosis is calculating by subtracting kurtosis by 3. Therefore, the excess kurtosis is equal to Kurt minus 3. Types of excess kurtosis. Number 1. Leptokurtic, where the kurtosis is greater than 3. Leptokurtic is having very long and skinny tails, which means there are more chances of outliers. Positive values of kurtosis indicate that distribution is peaked and possesses thick tails. An extreme positive kurtosis indicates a distribution where more of the numbers are located in the tails of the distribution instead of around the mean. Types of excess kurtosis. Number 2. Platykurtic, where the kurtosis is less than 3. Platykurtic, having a lower tail and stretched around center tails, means most of the data points are present in high proximity with mean. A platykurtic distribution is flattered, less peaked, when compared with the normal distribution. Types of excess kurtosis. Number 3. Mesokurtic, where the kurtosis is equal to 3. Mesokurtic is the same as the normal distribution, which means kurtosis is near to 0. In mesokurtic, distributions are moderate in breadth and curves are a medium peaked height. Thank you very much for watching YouTube channel ETV786, and thanks for watching the video. Please view, like, share and comment the videos and subscribe the channel to view latest update. Bye bye till the next show.